Hey guys, I'm going to mark up this periodic table and you can mark one along with me or watch or, just check what you may have left to put on yours. All right. So I've marked hydrogen here and I have a little line because I'm going to mark the alkali, and I'm not going to write in this box because remember, we're going to put francium there. So alkali metals. The alkali metals are group 1, right? So they go from here. They do go all the way down to here, but I am going to write francium, Fr for francium, because we're going to come back and make a special note about it. So the alkali metals are in group 1. They have one valence electron. They are so reactive that we do not find them in nature in their elemental form. They're always bound up in a compound. Then in group 2, we have the alkaline earth metals. The alkaline earth metals, that's everything in group 2, right? And then we also wrote that these are the transition metals. Transition metals, and they span all of this space, right? And include all of those things. We also know that this is the D block of elements, right? And then over here in the P block, we are going to make a special note about fluorine, right? So I'm going to put F there for fluorine, but then we also, now I'm going to write this the other way, so when I turn it, so this is the halogens, right? And the halogens do span, they do include fluorine, so all of those are halogens. They have 7 valence electrons, and so they also are highly reactive. They also do not exist in nature outside of compounds. They are going to be inside compounds because they're so highly reactive. And then, of course, here we have our noble gases. The noble gases are here, and that ranges everything in column 18. We know that all of these elements except helium have 8 valence electrons in the highest energy level. We know that helium only has 2 valence electrons there. Another thing that we were noting as we were going along, so I'm going to write in here, this is boron, this is carbon, this is nitrogen, and there's an O for oxygen. So those are those beginning elements. Sometimes it helps us to get our bearings there for what those are. And then now I'm going to take a pink marker, and I'm going to make my staircase for the metalloids. So I'm going to go down and over. So boron is a metalloid. Boron, and then we're going to come down to the side here, and then over and down and over and down. And so it's over 1 and down 1, right? So we can get it like that. Now let's, we said in the lecture that there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 here that we need to know. So silicon is 1, and then germanium is 1, and then arsenic is 1, antimony. Then sitting beside antimony is beryllium, and then we have polonium, and then astatine, AT, that's 1 as well. So so we say under the line, and we could take this line right here and go so on the line more there. So that's our metalloids. These are the metalloids. The metalloids are either on the line or under the line. Now we also made a note when I was talking, is that aluminum is going to be like an exception to the rule. Aluminum, I'm going to circle it up here. Aluminum sits under the line of the metalloids, but it is not a metalloid. We know that aluminum is a metal. It has all the characteristics of a metal, and so it is not a metalloid. Metalloids have characteristics of both metals and nonmetals. Also, as we're noting here, we note most of the things on the periodic table are metals. And in fact, if that's something that you wanted to do, you could actually You could actually, color them in and make your own sort of color coding here, right? That these are all of these are metals, right? Okay, all of these are metals, and we're not going to do our, right? So all of those are metals. I colored really lightly, so if I wanted to come back and write something else in, I could do that. Then if we are making it match our periodic table sort of in the book, then we can do the metalloids would be green here, so on the line and under the line, on the line and under the line, on the line, under the line, and then so astatine is a metalloid, but we'd also call it a halogen. That doesn't stop it from being a halogen, right? Okay, and then so those are those, and then if we want to do our gases, then if we're going to mark gases, we'd go back and we could do them in red, or our non. Well, these would be our non-metals, right? So not gases. I'm sorry. We're just going to do non-metals. Non-metals, then I'm going to do in red. I should have made that match the periodic table, but I did not. So here are our non-metals. Right? Some of them are gases. Some are solids. So we're not doing. Okay. So those are my gases. Sorry, I keep saying gases because I've picked up red. Those are the non-metals. Those are my non-metals there. And let me check one more thing before I. Oh yeah, radon. It's a gas. And xenon are gases. Lost. There we go. Gases there. All right. All the way down. And then this is synthetic. All right. So we can color it blue if we want to. We can color that blue. But it is one of our synthetics. Then we know. Oh, also we know that this is the lanthanide series. So as we're coming down here, so this would be number 4, right? So 4F and 5F, right? If we're doing that, so lanthanide series, and the actinide. Series is going to go all the way over there, right? So lanthanide and actinide series. So this is our F block, right? And then we have these particular names. So that's what I was talking about. The other thing that we did mention was how we know about valence electrons, right? So if you wanted to do a representative for valence electrons for each one, you could just put, so if you're in here, this column, this would be, this is lithium here. I'm sorry, beryllium. So this would be beryllium, and beryllium would have 2 dots, right? If we're talking about everything in column 2, then it's going to have 2 dots. Everything here, so these would all have 3 valence electrons, and then 4 valence electrons, 5 valence electrons if you're in 15, 6 valence electrons if you're in group 16, 7 valence electrons. Now, we might want to put 2 valence electrons on helium, right, to know that it's different than neon. These others have, so neon would have 8 valence electrons. We're just thinking about other things that we can know right away from the periodic table. I'm going to go back over these: carbon, nitrogen, oxygen, and fluorine. Now, we'll use this later, too, when we're talking about our trends, our periodic trends, but the basic layout then lets us know that these have 1 valence electron, these have 2 valence electrons, 3, 4, 5, 6, 7, and then 8 valence electrons except for helium, which only has 2. So I hope that that clears up anything that I might have gone too quickly on, or you couldn't see it before. So if you mark this up, then you should have no trouble. Let's do this one thing. Francium, right? So we talked about francium being here, right? So francium is the most reactive of these because it's valence electron is in the 7th energy level. And then, of course, fluorine, we're going to talk about fluorine's electronegativity and what that means for it. So we noted it as well. So we'll be adding some more information about that, right? So I hope that that helps you. Also, you might want to note bromine. So bromine is right here. This is that was the other liquid. Bromine is a liquid at room temperature. You can't see that bromine there. And then in row 6, where are you? Polonium. 1, 2, 3, 10, 12. So this is mercury. All right. So if you want to mark mercury as a liquid and bromine as a liquid, those are our 2 liquids at room temperature.